Hi. Okay. Good morning, good afternoon, and good evening to our audience around the world. Thank you for giving us the opportunity to make this presentation here at the SIEW Energy Insights. So maybe a little bit about A-STAR. A-STAR is a statutory board belonging to the Ministry of Trade and Industry in Singapore. And our mission is to advance science and innovative technology to further economic growth and improve lives. We are a part of the Singapore R&D landscape, and we cross-leverage our partners across the Singapore ecosystem to achieve our positive outcomes for the various national priorities that we have. Next slide, please. So Singapore being an island nation and a city-state that we are, we see that enhancing our living environment to create smart, sustainable cities is an extremely important part of our mission. So next slide, please. In this vein, two of our national priorities are mitigating climate change and ensuring that our built environment remains competitive. This is a running theme that you would have heard across this entire SIEW presentations. The current COVID situation has indeed hampered some of our efforts, but we are more determined than ever to achieve a resilient and sustainable city of tomorrow. Next slide, please. A-STAR recently set up an urban and green tech office with the mission to coordinate research across our research institutes in this space. As a part of the Singapore R&D ecosystem, we want to be able to be an active and value-adding partner in Singapore for research in urban and green technologies by focusing on niche areas based on our comparative advantage. Next slide, please. The areas that we are focusing on are in CCUS, carbon capture, utilization and storage, hydrogen, energy efficiency and electrification, infrastructure or our built environment, and waste valorization and sustainable manufacturing. And we are supported by several enabling technologies in the spaces of life cycle assessment, modeling and simulation, and digital technologies. Next slide, please. Some of the research priorities that we have are listed here, be it in sustainable building materials, electric vehicle charging stations, construction robotics and automation, plastic recycling, and waste sorting. We also have a pretty large effort going into looking at how we will work in sustainability in manufacturing. Next slide, please. So zooming into the pillar on energy efficiency and electrification, some of the sub-areas of focus are in battery technology, power conversion, grid technology, and electric motors. So my colleagues, Professor Alex Yan and Dr. Chiam Yang will be going into a bit of a greater detail about their work in one of these sub-areas of battery technologies. Next slide, please. We view life cycle assessment and more generally even life cycle thinking as crucial elements for our journey into sustainability, which is, as we have defined here, to improve resource efficiency and achieve science-based targets through resource management. My colleague, Dr. Yeo, will be speaking a little bit more about our work in that space in his presentation. Next slide, please. So just as a slight summary, this is an overview of the various talks that you're going to hear in this session on recycling of e-waste and lithium-ion batteries, launching battery repurposing white paper, and also to understand the environmental impacts of products and systems through life cycle assessment. Next slide, please. And with that, I thank you, and I'll hand this over to Yang for his presentation. To Professor Alex Yan for his presentation. Thank you.
Thank you, Professor Kumar. It is now my pleasure to invite Professor Alex Yan, School of Materials Science and Engineering, Nanyang Technological University, to give his presentation. Professor Yan, please.
Good morning, everyone. Good afternoon to good afternoon, good evening to everyone else. So today, it's my pleasure to give an introduction to the electronic waste recycling and lithium-ion battery recycling set up in our program, joined by NTU and CEA from France side. We call it the NTU Singapore CEA Alliance for Research in the Circular Economy, we call it SCARCE. So this program is led by Professor Madhavi and Dr. Jane Christoffel from CEA side. So today's presentation I will give, I give it on behalf of Professor Madhavi. Okay, so next slide, please. So why we are interested in e-waste, I probably need to click one more time. Because there's a huge amount of electronic waste generated every year. Please click one more time. So in Singapore, there are 60 tons of e-waste generated per year. This is data by NEA. Next slide, please. Okay, yeah, please show the whole screen. Click until the whole screen. Yeah. So, so we together with CEA, and also we work closely with the National Environment Agency of Singapore. We set up this SCARCE program, and in this program we have 4 thrusts. First one, recycling of lithium-ion battery. That's what I give detail today. We also work on recycling of silicon solar cell. And myself working on the third thrust is a recycling and recovery of printed circuit board. Lastly, we were also working on the recycling of the plastic of e-waste. Next slide, please. So the scope of this SCARCE, we are mainly focused on the TRL4 and the between TRL4 and TRL7. So close to the industrial application. And we will give a prototype demonstration in a relatively large scale. Next slide, please. So today I will give a detail on the recycling of a lithium-ion battery, which is led by Professor Madhavi and Daniel Mayer from CEA side and Andre from CEA side. Next slide, please. So the reason we are interested in a recycling of a lithium-ion battery because first of all, we have a huge amount of lithium-ion battery, used lithium-ion battery generated every year. And also in this kind of battery, there are a lot of heavy elements. In some countries, especially in Europe, they are considered to be toxic, like cobalt, manganese. And also they contain the hazardous species like HF. And they can generate, during the operation, they can generate the CO and the CO2. Next slide, please. So currently the state of art for lithium-ion battery recycling in the world, they are mainly focused on the 2 techniques, pyrometallurgy. This is a very high temperature process, require a lot of energy, or they have a hydrometallurgy. In this process, they require very strong acid. So they have an environmental concern. They give a gas emission like HF. Okay, so which is not very environmental friendly approach for both. Next slide, please. So you can see from this map, the battery recycling industry normally currently mainly located in North America, Europe, and Asia. But if you look at those company technology, mostly pyrometallurgy, and some of them also work on the hydrometallurgy. So in order to make a good profit, also try to increase the efficiency, we have to improve the recycling technology. Next one, please. So this is our scope on the battery recycling in the SCARCE. Typically, we are working on the new lithium-ion battery. We try to build up new lithium-ion battery from the used lithium-ion battery, but recycling their useful component and also the element. The overall high recycling efficiency, our goal is by end of this program should be about 90%, and we should achieve 80% extraction of our constituent element in all the demonstrated lithium-ion battery, no matter what cathode material it is. And we will try also do the second life reusage of material, whichever has been demonstrated in the lithium-ion battery recycling. Next slide, please. So in this process, we're starting with battery shredding. Means that when we get the used battery, of course, we first do a sorting based on their materials, and then we will do when we say material, means a cathode material, either lithium iron phosphate or lithium nickel cobalt manganese oxide. Then we will discharge them. We will put them into this mechanical shredder, and then we get this black powder. Next slide, please. So the overall process will be illustrated well by this process map. You can read it from right-hand side to the left-hand side. We're starting with a used lithium-ion battery. Then we shred them and make a black powder. And then we have to do leaching and get this leaching solution. And then we try to precipitate out the useful element from those leaching solution. And finally, we get this extracted the useful element or useful chemical. And finally, you can see the loop can be closed from the top left-hand side to the top right-hand side. From the extracted chemical, we can remake the lithium-ion battery and reuse them. Okay. Next slide, please. So some of the demonstrated results shows that when we use the new battery electrode material made from this extracted used battery component, we can make a pretty well lithium-ion battery with a very good performance, with a very low polarization, long cycling performance, and good fast charge discharge capability. Next slide, please. In some of the steps, especially the leaching step, which is that traditionally we will use a very strong acid. So we will try to use a greener approach. Instead of use strong acid, we try to incorporate this bio approach, and which will much environmentally friendly, and this can also increase the either increase or close to the efficiency for the traditional hydrometallurgy process. The bio approach, we can use those either orange peel or food waste, this kind of naturally friendly component to do to help on the leaching process. Next slide, please. Even for the plastic container of the battery, we're also thinking of recycle them and made into a useful component. One of the examples is that we can process the plastic waste component and combine with a metal sort, make a metal organic framework, which is a very useful material. Nowadays, it can be proposed for a variety of applications, including gas storage, including the membrane separator. Okay. Next, please. Next slide, please. Yeah, this is some of the example we have demonstrated to recycle the plastic component and made it into a metal organic framework. And it depends on the sort. They can be different metal organic framework product can make. Next slide, please. Next slide, please. Yeah, this is a finishing of my presentation on the lithium-ion battery part. If you still have a little bit of time, I can show you just 3 more slides on the general introduction of other 3 thrusts of the SCARCE program on the solar cell. On the this is this is an overall picture of our group for the SCARCE. Next slide, please. Next slide. So one of the research direction led by Nirupam, he's working on the recycling of silicon solar cell. We try to dismantle the silicon solar cell, reuse the silicon wafer, recycle the silver paste component, and extract the valuable product. Next one, please. So my one will be on the recovery of the valuable metal from the printed circuit board. We still use the a green approach of hydrometallurgy. It's similar like a battery one. Next one, please. Last one will be the recycle of the plastic component. Yeah, I think time is over. Anyway, this is my last slide. I finished. Thank you.
Thank you, Professor Yen. We would now like to invite Dr. Chiam Sin Yang, Director, Singapore Battery Consortium, to share his presentation. Dr. Chiam, please.
Hi, good day, everyone. This is Sin Yang here. So firstly, I think thanks Alex for giving a very good introduction about battery recycling. I'd first like to thank you for taking the time to be here, and then Dr. Hee and the organizers for giving us this chance to share some of our work. So basically today I'll first like to introduce the Singapore Battery Consortium before I talk briefly about our work with our co-authors, IPI and NTU SCARCE, on repurposing of batteries. And finally, maybe if I have the time, I'll share a bit about the local ecosystem in both repurposing and recycling. Can I have the next slide, please? So the Singapore Battery Consortium is an effort, a national level effort funded by NRF. And you can see we are guided by the steering committee as listed. We really want to be the focal point to try to bring together both public and private players to push in the space of innovation for battery-related technologies. And we look at this primarily in three spaces. The first one is battery pack and modules. There's battery materials and cells. And today I'm going to talk a little bit about battery repurposing or battery reuse. But if there's any interest in other areas, do feel free to contact me. The next slide, please. So the consortium currently has 29 industry members, as listed here. And I think we have about 56 academic or researchers in our consortium as well. And we organize plenty of activities and events. And we also do try to help our members by looking at market technology intelligence. And I think the battery repurposing white paper that we are launching today is part of that effort. So the next slide, please. So as Professor Alex mentioned, I think there's going to be a lot of waste batteries going forward. And the repurposing of lithium-ion batteries is one of the ways we can try to make battery technologies a more sustainable part of our ecosystem. And so in this white paper, what we've done with IPI and NTU is try to look at the technological aspect and also the market side of things in the repurposing of lithium-ion batteries. So do reach out to us and contact us if you want more information and access for the white paper. The next slide, please. So first, I think one of the things we focus on is to look at the processes and the challenges for battery repurposing. So I think battery repurposing itself, we need to look at where the battery comes from. How are you going to disconnect it? How are you going to transport it, dismantle? And then there are several pathways for this to happen, depending on whether you have historical data from the OEM. Then it goes through a process of whether you look at whether there are degradation in the batteries and which can be repurposed, which can be rejuvenated actually. And we identify some of the challenges and gaps in both the repurposing and disassembly in this work. The next slide, please. We also take a look at the market side of things. That means the value chain, the companies in this space. We try to look at the players who have deployed second life batteries. And this is on a global scale that we try to look at this, both, I think, with a view for Singapore, but also in the region and globally. The next slide, please. And part of the work, especially helped by IPI, is to look at the patent landscape for the different technology areas. So one we look especially at is on battery diagnostic, grading, sorting, rejuvenation of the battery. The second one is on actually battery pack and module disassembly, and especially on whether this can be automated, and because that is where the innovation will lie and where the differences might be. The next slide, please. And we not only look at a very high levels look at the numbers, we also try to take a closer look at each of the technology, especially the important ones. And so what we see here in the disassembly system is try to look at the IPs, what are the, for example, unscrewing technology involved, whether that can be automated. And for example, in rejuvenation, what are some of the IPs that have been filed by the key players and what they are, and try to explain a bit and look into the technology itself. The next slide, please. And so that is the content for the white paper in general. There's a look at the technology, there's a look at the market side. And for the consortium itself, I'd like to introduce the ecosystem that is in the space of both repurposing and recycling. And there's quite a lot both directly involved and also indirectly involved. The next slide, please. So I highlight a few players, for example, DuraPower. So DuraPower is cell manufacturers all the way up to the pack, and they are solution providers for e-mobility, and for example, stationary applications. And they have had used batteries coming back, and because they have supplied to many of the mobility operators, and they have the batteries coming back, and they are looking very keenly at, and they have deployed quite a big sizable number of second life batteries already. The other company is GenPlus. So GenPlus looks at stationary application primarily, and they have now a very good system to evaluate and deploy second life batteries for their customers, and they are very focused on making their process sustainable and tying up responsibly in the disposal process. The next slide, please. And I think I want to highlight some of our partnership the consortium has. The first one is with UL. So we signed an MOU recently this year to really strengthen our ties in looking at battery standards and battery safety science. I think one of the key things, if you look at battery repurposing, the UL 1974 standards is probably the most comprehensive in terms of in the value chain of repurposing of batteries. And I think we're organizing a lot more. We have organized some seminars with UL, and we're going to organize a lot more. Look out for one coming in January, where we'll be organizing a masterclass series for battery safety and standards that includes second life batteries. Siemens is also one of our members and a key partner. They have the solutions, for example, to do a very comprehensive and fast design of both new and second life battery systems, and they do it through a multi-physics approach. There's going to be a workshop coming up to let you understand more about their solutions. So this is coming up pretty soon next month. And with VDE also, we have done a few seminars on battery handling, battery safety part. We're going to have a training workshop actually coming up in December. And this is actually with also another partner of us, Hioki, will come in to look at training on the battery analyzing part. And so from this, you can probably tell that a bit about what the consortium is trying to do. So leveraging on our industry partners, leveraging on our IHL partners, what we try to do is to not only push on the innovation space, but we try to create a dialogue, try to create the opportunities possible for people to come together and talk about having solutions for very difficult problems, and to lay the groundwork for hopefully a good ecosystem within Singapore. The next slide, please. In the battery recycling space, which Professor Alex Yen talked a little bit about, I just want to share very quickly. Within the consortium, we have Green Lithium Ion, a very innovative startup that looks at hydrometallurgy, and looking at their technology. I feel that is quite exciting, and they have already existing customers for them. And also SYH. So SYH is an e-waste recycler, and for their battery recycling facility that's based on pyrometallurgy, they can do about 1,000 tons per month. So also like to mention TESS, of course. TESS is a very big recycling company in Singapore. They are doing about 14, they can do about 14 tons per day of battery recycling in a new facility. The next slide, please. And then I think Professor Alex Yen introduced about SCARCE, so I'm not going to talk a lot more about that. But to also introduce the other players in this space, including NUS, Temasek Poly, who looks at redox recycling processes, which is, I think, a very interesting upcoming technology that is cost-effective and really we can really look at a continuous process instead of a batch process for recycling. The next slide. Yeah, so I think in conclusion, the battery recycling space and repurposing space is very important, and it's one of the areas we look at. Just to share again that the consortium itself looks at quite a few areas, and we have quite a lot of members within the local ecosystem and also beyond. We are a good network of both companies, scientists and academics, where we come together to try to push on this space in innovations for batteries. Thanks.
Thank you, Dr. Chiam. For our final presentation this morning, we would like to invite Dr. Yeo Zhi Quan, Deputy Group Manager, Sustainability and Life Cycle Engineering, Singapore Institute of Manufacturing Technology, SIMTech, for his presentation. Dr. Yeo, please.
Thank you for the introduction, and good morning, afternoon, and evening to everyone joining this session. So as we move forward, developing technologies and solutions that are more sustainable, as well as such as introducing and implementing concepts such as recycling, cascading use, or upcycling, there is also a need to validate such strategies. That these strategies does indeed contribute towards a more positive environmental impact and moving towards sustainability. So in this session, I will share about how life cycle assessment can contribute towards validating such strategies. Next slide, please. But first of all, let me begin by highlighting some of the key sustainability challenges that Singapore faces. So first of all, if we look at the aspects of fulfilling our energy needs, more than 95% of it is realized by burning fossil fuels, based natural gas. And on the other hand, we also face constraints in deploying renewables due to our land constraints. So in terms of water, we also import up to 50% of the supply currently, and constrained again by our space for having more reservoirs. And to keep up with our waste generation activities, we also need to build new waste to energy plant every 7 years. But again, our landfill site is going to be at full capacity by 2035. And again, to feed ourselves, we rely more than 90% on imports, and yet again constrained by our land to engage in conventional agricultural activities. So again, this backdrop, our population is also growing, and like all other countries globally, we face the effects of climate change. And specifically because we are an island surrounded by water, we are also at risk of losing 1/3 of our land due to this rising sea levels. And if that happens, there'll be widespread cascading impacts, because a lot of our critical activities are already carrying out within our constrained land space. So next slide, please. So at this international level, in particular to target the challenge of climate change and carbon emissions, Singapore has already made long-term commitments in terms of our nationally determined contributions, as well as long-term lower emissions development strategy. So next slide, please. So this translates to our key technical challenge in Singapore of how to balance the interrelation between energy, water, waste, food, our land, as well as our carbon emissions, and to progress towards a more sustainable development approach to support our economic activities. Next slide, please. So fundamentally, our economic activities and its interrelation with the environment can be summarized in this life cycle diagram. Most, if not all, of our economic activities begins by acquiring natural resources as raw materials for producing goods and services. Then we consume those goods and services, and we dispose them, at the end of life. So in every phase of our activities, we are either placing environmental loads or demands on our environment. And because of this, when solving sustainability challenges, we need to adopt a holistic approach which considers the impact of the entire life cycle, rather than focusing on only a particular single phase of this life cycle. Because in environmental problems and solutions, there's always a pitfall of what we call problem shifting, whereby we solve a problem in one area and we create other unintended consequences or problems, either upstream or downstream in the process or this value chain. So therefore, in order to mitigate problem shifting, there is a need to make evidence-based decisions in our pursuit of sustainable development, and it really requires a life cycle perspective to it. Next slide, please. So this is where life cycle assessment, or LCA, plays a part, as a tool in this decision-making process. Next slide, please. And just to quickly run through what LCA comprises. So LCA is a methodology and has an ISO standard for it. So it comprises 4 key phases. So in this first phase of goal and scope definition, really starts by framing up the study. This is whereby, amongst other things, we define the key questions to be answered. For instance, is deploying a particular technology really more beneficial than, say, a business as usual scenario? So in the next step, once we have scoped the study, and most importantly, knowing what the question we want to answer, we go about collecting and preparing the necessary data to build up this case. So this data will include, things such as process flow diagram and mapping, finding out the various resource flows flowing in and out of individual processes, and collecting, energy consumption as well as other resource consumption data and quantities. Then in the next step, after data collection, we convert those raw data into relevant environmental impact indicators. Again, we can think of this as KPIs from the environmental perspective, such as global warming potential, which really measures the amount of greenhouse gases being emitted to the environment in terms of mass of carbon dioxide equivalent. So at this stage, we have, sort of established a model of representation of reality and furnished with the necessary data. And in the final step, we can do the interpretation of the model. So I think that will be the next slide. We interpret the model to sort of answer the questions we asked in the first step. So this could involve creating scenarios using the life cycle assessment model to do what-if analysis and observing its sort of impact when we make certain decisions. And from there, we can actually make quantitative comparisons to the results. So in the next section, maybe let me illustrate some case studies of what kind of questions LCA can be used to answer. So let's start with a little bit more of a relatable case in our present day context of the global pandemic. So because of the pandemic, there was this surge in mask usage. And again, linked to that, there is more sort of increased pollution due to this disposal of masks. So the key question we asked here was, is using reusable masks better than using disposable masks? So, this may appear a straightforward question, initially, but using reusable masks requires washing and detergent use, whereby in the case of using disposable masks, no such activity take place. So can this washing activity be really detrimental for the case of using reusable masks? So this is sort of a side question that we asked. So the answer, as it turns out, is not that straightforward. That is, using reusable masks will be better in terms of carbon footprint if we use it for more than a certain number of times. So in this case, 8 times. And again, this is only one aspect of the problem. And if we were to look at the next slide, we examine this same question from the aspects of solid waste generation. So, again, using reusable masks will only be better if the number of usage cycles crosses a certain number of usage, which is 6 times in this case. So the conclusion is that, using reusable masks could be potentially better, but provided, it fulfills certain conditions of usage. So in terms of, this crossover point whereby using reusable masks is better, so it really depends on what kind of environmental impact we are also, interested to look at. So again, educating ourselves on the different type of conditions that, certain usage case is better than the other is also a useful, element in making decisions. So in the next case, we examine the development of carbon dioxide mineralization technology that is, again, using carbon dioxide to produce more valuable products, in this case, sand substitute. So the question we asked here was that, compared to business as usual, whereby we don't deploy this technology, is this technology deployment a better alternative? So the answer oftentimes is not apparent, because if you think about it, the process of mineralization also uses energy inputs. So if there is too high of an energy input requirements, and again, depending on how we generate the energy usage, the energy in the first place, it may potentially offset any benefits the technology may bring. So if we perform this LCA study, we are able to quantify these factors and provide more quantitative evidence to make more sound comparisons. So in this case, this particular case, rather, the LCA results tells us that indeed, if this technology were to be deployed, overall there is still a net abatement of carbon dioxide from the environment. And again, additionally, a bonus is that it produces sand, which can help supplement our current supply, which relies mainly on imports from our neighboring countries. So in the next case is where we examine using LCA applied on technology development of PV technologies. So this work was again in collaboration between SIMTech, NUS, as well as SIEW. So this is a comparative LCA that we have done, between aluminum back surface field versus passivated emitter and rare cell technologies. So the results show that there is some advantage of ALBSF in terms of energy payback time as well as greenhouse gas emissions. However, it is also highlighted that light-induced degradation is also a potential factor which really can diminish the advantage of this ALBSF technology. So this is where technology development has also to place more attention in order to successfully make it more advantageous from the sustainability point of view. So in the next slide, which is again the final case that I have to share here today, is one that relates to the case of closing the loop in relation to the circular economy. So, this study really examines the case of e-waste recycling, specifically on the case of flat panel display monitors. So if we were to incinerate the monitor at this end of life, it will again create lots of significant amounts of carbon emissions due to the burning process. And again, the one way is to establish a closed loop manufacturing system whereby you take the materials at the end of life and giving it a new lease of life, either through deriving the original materials or through remanufacturing or refurbishing certain components to it, whereby you put it back into later part of the life cycle stage. So using LCA as an analysis tool, we are also able to obtain granular analysis of the individual components of the products. So from from there we can tell which component has the greatest reduction potential. Again, because in complex electronic products such as monitors, as well as perhaps even electric vehicles, it's product which comprises many subcomponents. So depending on what the component is, there are varying degrees of advantage if we were to establish closed loop recycling for. Again, so in this case, we found that again, particular material, which is the ABS, presents the most opportunity for reduction if we could establish the closed loop system to recycle them. Right. So so now again, to conclude off, I'm just going to go through some of the key takeaways related to LCA. So first of all, in order to pursue sustainable development, so there will be many technological pathways and options that are available. So there is really a need to be, to make decisions from an evidence-based approach, as to, such as making decisions such as what are options to deploy and under what circumstances. So sometimes the answer may not be as straightforward, as the advantage, oftentimes are conditional, as we can see from the, even the seemingly simple case of reusable mask versus disposable mask. So only by performing an LCA study, then we can have a little bit more quantitative evidence to determine what conditions these are and how much difference does it make through these different environmental options. So I think we need to click a few slides more. Okay, yeah, thank you. And finally, through this evidence, we hope that, collective and collaborative decisive actions can be implemented to progress towards achieving our sustainability goals. So with that, I'll end this presentation and thank you very much for the attention.
Thank you, Dr. Yeo. We would now like to invite Professor Kumar, Professor Yen, Dr. Chiam, and Dr. Hee to join the discussion with Dr. Yeo.
Thank you very much, Kylie, and thank you to the panel for a very informative sharing on the Urban Green Tech Office area of focus. And I really look forward to reading the white paper on battery repurposing. And for the first question, I thought we could warm up a bit by, having a question for all the panelists, so you can choose to answer, if you would like. So my first question: policymakers and planners often face the energy trilemma of balancing between economic competitiveness, environmental sustainability, and energy security. Could the speakers share your thoughts on how your work can support meeting, balancing between these needs? Perhaps Professor Karthik can start.
Thank you. It's a very interesting question in terms of the energy trilemma. One of the ways that we work, at least in the research ecosystem space, is trying to think about how technology can help us solve at least some parts of this research trilemma. But in order for us to do that, we need to bring everything onto a single basis for us to compare where the different efforts need to go into. And one area that you would want to that we are looking at pushing through is not only in terms of life cycle assessment, but in the more broader space of life cycle thinking. And I think in the policy space also, in some of the concepts, especially what Chiam mentioned or Dr. Yeo mentioned in his presentation, they can be brought into the whole thinking to try and bring all of the different concepts that we have to look into, be it security, be it the environmental aspects, bring them onto a single platform in order for us to assess where the impacts are going to be and look for the best possible solution in those circumstances. Thank you.
Any other takers for this question? Okay, if not, I will ask some of the more specific questions that we see coming in. Again, Professor Karthik, maybe we start with you since you did the first presentation. The question is, what role does the UGTO play in supporting battery-related R&D within A*STAR and with external parties?
So some of the work that we do is, first of all, the UGTO was set up in order for us to provide a voice for all of the research that we are doing within A*STAR that pertains to this space, and battery research being one of them. So we sit in various national committees that are discussing various different issues, be it how we are going to roll out electric vehicles into Singapore, or whether it goes into waste valorization, waste or recycling, etc. And what we try to do is to make sure that we are able to pass the message to our different sub-pockets of research communities to try and respond to these different national priorities. In that vein, what we also do is to help to look for funding, because that is a key enabler for us to be able to do this type of research as well. The other aspect that we do is to try and bring the community together in terms of putting together operational technology roadmaps across various different spaces. Most recently, one that was done and sponsored by our office was on energy storage systems. This was, I think, released last week. This is one example of how we try and bring the whole ecosystem together to look at how we want to chart a pathway forward. Thank you.
Thank you, Professor Karthik. My next question is for Dr. Chiam. What role do you think Singapore Battery Consortium can play in the Singapore energy story?
Hi, Dr. Hee. Thanks for the question. So I think this also covers a bit on perhaps your first question on the trilemma. I think the consortium wants to look at a space where, so innovations is a space definitely that we want to push. And the way I look at it is that sometimes if you leave market to their own mechanism, the companies might have some blind spots that they might not want to explore because it's costly, because this is not there for them yet. It's the same thing for IHL and researchers. They are looking at very innovative technologies. They're looking at chasing the breakthrough in the science. So I think what we play in the role is really to look at possibly blind spots for these two and to bring them together, where we can see that this can be an area of importance for the company down the road in terms of how it might benefit them, and also to then inform the researchers and academics that this is actually a space that can be very important for you, even though it might be a little bit more applied. And I think then this is the role where we can help to guide this conversation between the two parties, and also then working with UGTO or different agencies to help understand also the public side of the demands and the public side of the requirements in our energy story. Thanks.
Thank you, Dr. Chiam. The next question is for Professor Yan. There's a lot of curiosity if there's any increase in cost when choosing greener recycling processes as compared to the conventional processes like pyrolysis and hydrometallurgy?
To my understanding, I feel it's not necessary to increase any cost. The idea, we try to use green approach, try to reduce energy consumption and also avoid a lot of environmental issues. So the whole process will be carried out in a close to the more ambient condition rather than in a protective environment. So in this case, I was thinking maybe it will be even lower, push the cost even lower and make the efficiency even higher.
Okay, thank you for that. And this next question comes for Dr. Yeo. There is a general perception that sustainability leads to higher costs for companies to meet regulations and policy. Does it make business sense for companies to adopt sustainable practices?
Yeah, thank you, Dr. Hee, for the question. So again, cost and sustainability has always, from the business perspective, has always been sort of a dilemma. Should I practice sustainability, or should I just go about and lowering my cost at all costs? But again, I think if we to examine the question in the first place, businesses they have to understand that their business activities, either directly or indirectly, are actually causing some form of environmental impacts. Be it some of the activities are a little bit more visible because some companies, they burn fuels on site and then thereby they release some emissions. But even if we were to plug in, from the socket and draw electricity from the national grid, we are also causing, some form of burning of fossil fuel at, some power station. So this is the fundamental of how business activities and sustainability, business activities, and as well as related to sustainability and its impacts. And again, the government is starting to realize this, and they are also trying to put businesses to be more responsible for their actions that they have, causing this kind of, global warming issues. So again, we are already seeing some form of actions by the government, such as introducing a carbon tax, as well as, in the future, we will be seeing this concept called extended producer responsibility, where businesses will be mandatory for them to take responsibility of the waste that they generate in the future, which is going to happen 2-3 years down the road. So again, although this sounds like a stick approach, but again, if the companies are prepared beforehand, before these regulations take place, then again, it wouldn't really be an increase in cost, or rather their cost increase may be mitigated. And if they are more innovative, they can actually sort of find some kind of new revenue streams from all these regulatory changes. But of course, this is a stick approach, and let's say we look at the problem from a more carrot approach, whereby again, to be sustainable, you do not need to, for a start, you do not need to deploy fantastic or rather sort of rocket science kind of technology. But for starters, you can actually start from very small actions, such as even placing more focus on how to operate your business processes more efficiently. That will again in turn lower your energy cost, and that would be actually a good starting point to operate more sustainably. And then from there we can actually move on to continuously improve on different processes. Yeah, so through the process, businesses will be inevitably enjoying cost savings through all these better practices. Yeah.
Thank you, Dr. Yeo. This might be a good opportunity to bring Harsha back to the discussion, because SP, as you have shown us earlier in your presentation, is clearly pushing for sustainability. So what is the business sense business case for sustainability here?
Well, it's definitely a hard one, right? I always say that everyone wants to hear and talk about sustainability, but no one wants to pay for it, and it's always the case. I think what's encouraging to note is that there is definitely a much larger sense and awareness around a person's or an organization's impact around sustainability today. And I think there's a fairly global push to have organizations, businesses really think about how they manage their businesses sustainably, how they impact the environment, how they impact people or communities where they operate in and around, and how they contribute to the sustainable development goals holistically as well. So I think there's awareness that's being built. There's push from a multitude of different directions. We also note that in some cases where businesses are demanding, larger businesses are demanding that their supply chain meet certain sustainable credentials before they get selected as an approved vendor as well. So I think these things are all coming together. And as a nation, as in, Singapore, I think we have a great opportunity to take the lead in demonstrating how we organize ourselves, how we look into this whole aspect of sustainability, build policies around it, and also encourage businesses, individuals to participate actively in it and contribute towards, climate mitigation and also towards, not just national sustainability goals, but how do we then take these things and promote it externally to the larger world, and how do we take a lead in it? Coming back to your question around, is there a business case for sustainability? I think a multitude of these, push that's coming from different directions are definitely going to get, have people start thinking about sustainability very differently. There will be a lot of transformation from an economic standpoint, from a business, commercial standpoint. So we will need to really look at how all those things can come together to drive a viable, sustainable business and make it easier for people to adopt sustainability holistically. I hope that makes sense, Dr. Hee.
Yeah, that makes a lot of sense. Thank you, Harsha, for sharing the business perspective. The next question is for Dr. Yeo. In your view, how common is closed-loop manufacturing adopted by the industry? And what barriers are there, and what can be done to encourage companies to take on a life cycle assessment approach?
Okay, so I think for a start, closed loop manufacturing hasn't been the common practice yet, because again, our economy has been built for decades, sort of a linear configuration whereby we take raw materials from one end, and then from there we manufacture, we use from the consumer point, and then we dispose it off. But of course, we are actually starting to see these closed loop manufacturing sort of systems at a macro level are starting to sort of take place, especially in the European regions where they have already enacted what they call the extended producer responsibility. So for certain items such as e-waste, it is mandatory for the producers to take back, all these, products at the end of life. So given that, there is this regulation, to compel producers to take back all these materials, at the end of life. So again, these are, for a start, it's a added cost. But how do they turn these costs into revenue opportunities? This is where they look into innovation, through processes such as how do we remanufacture certain components to put it back into the system. But at the same time, of course, you need to ensure that the performance performs just as well as the products that are newly manufactured. So all these innovations, we do see it in various sectors, as well, not only in the electronic sector, but as well as, say, manufacturers of, say, heavy equipment. They are also practicing all these closed-loop manufacturing systems. So again, to implement these closed-loop manufacturing, you have to introduce some innovation and technologies. And again, these are the opportunities for companies to innovate and engage in research and development activities to ensure that these closed-loop manufacturing system will be reliable. And again, this is where a lot of improvements that can also be made. And again, we can work towards closing the loop for this whole economy. Yeah.
Okay, closing the loop.
Yes. So again,
closed loop manufacturing. Yes.
yes.
Mhm.
In my view, there is some, of course, definitely some technical challenges to closing the loop, because again, certain ways of closing the loop, sometimes you may, introduce additional energy consumption, and at the end of the day, we need to sort of employ a life cycle thinking and apply life cycle assessment to really quantify, is deploying certain sort of strategies to close the material loop or even close the energy loop. Does it really make proper sense? Yeah, in these aspects. Yeah.
Okay, thank you, Dr. Yeo. The next question is for Dr. Chiam. The question would be, how important is battery recycling and repurposing for Singapore, especially with the current emphasis on circular economy? And the second part of the question is, what do you foresee are the main challenges in achieving high rates of battery repurposing in Singapore?
Thanks, Dr. Hee, for the questions. And I think the two questions are probably related as well. So I think on the first one, if you are looking at how important is battery recycling and repurposing, I think if we are going really for full electric vehicles for Singapore by 2040, you are looking at used battery coming online from 2030 from about probably 100 megawatts to 2040, maybe about even 10 gigawatts hours of batteries. And that's a lot. And we need to be able to to dispose of them responsibly, or to make use of them, to give them a second life. Of course, you can talk about shipping out the batteries, shipping out the waste. That is one possibility, of course. But I think gradually we are seeing more and more. Firstly, that is not an easy thing to do. Secondly, there's more and more resistance in moving waste around between different countries. But the second part of the question, which is on the challenges, then I think comes back to the discussion of whether sustainability is a profitable business, as was discussed just now by Harsha as well. And that is a challenging aspect because it is costly to be sustainable. But as Harsha mentioned, there are multiple factors that is pushing us in that direction. And as Minister Chan talked about a bright green spark on the first day of SIEW, this is one possibility for us where we can show the world that and make Singapore as an example. And I think battery repurposing and recycling is definitely a space with the ecosystem that we have to make a difference in how we do things. And so looking forward, I think it is definitely a possibility where we can be even the center for the region in terms of getting in batteries to repurpose and recycle. And then it makes a lot of economic sense for us to do that. And at the same time, we can achieve our national goals. That's how I see it. Thanks.
Okay, thank you, Dr. Chiam. On a related question for Professor Yan, how long before we can expect battery recycling to be a widespread practice in Singapore?
Yes, this is a related question to Singa just mentioned. To me, I think right now, many of current Singapore local industry, they are working on just the sorting of different components and then repurpose for different application. Really, in Singapore, we don't do much on pyrolysis or hydrometallurgy because that's very environmentally concerned and not accepted by a local industry standard. But with our development, if the green approach with in the ambient without any strong toxic species involved, I can foresee it's possible for Singapore to take up this industry. The challenge right now is one side is scaled up, for large quantity of recycling. Second would be the revenue, balance between the investment and the profit. I wish maybe in the time between 5 to 10 years, we can see some startup company in this business. Yeah, thank you.
Okay, 5 to 10
Dr.
years.
Hee, may I add
Yes,
to respond?
sure, yeah, of course.
So I think the recycling space, if you look at it, for certain chemistry is already profitable. So for example, if you look at the high cobalt content LCA type of batteries from consumer electronics, that's actually already profitable to try to extract the cobalt, because cobalt is quite a precious commodity. And but for some battery chemistry, not so. And I think to make that profitable going forward, that's why we're looking at this repurposing that includes direct recycling, which means can we recycle this into a higher value product, for example, ready cathode materials to be remanufactured into batteries. And that really is of a higher value. And so there are a lot of still a lot of challenges in making such process both economically viable but also environmentally friendly. And I think but I do see this as a very high potential area both for Singapore and for the region. Thanks.
Hey, thank you for adding to that, Dr. Chiam. The next question is for Professor Karthik. The technologies that are being developed for recycling batteries, are they just limited to Singapore, or are they also being utilized by other developing countries which have huge amounts of e-waste generation? For example, the example given here is in India. What are your future plans regarding this?
Thank you for the question, Dr. Hee. So, basically, what we would like to see is how we can develop enterprises in Singapore that would scale globally. And so, what that would mean is that if we can find companies that can do this kind of recycling here in Singapore and export the technologies through these companies, that would be a win for what we would like to be able to do. So enabling the local companies to be able to play on a global scale would be the main thing that we would like to look at. Thank you.
Thank you, Professor Karthik. The next question is open to all the panelists. It's a kind of more forward-looking question, which asks, what technologies are A-Star working on that you think would have the greatest impact in the low carbon energy transition? And on a related question, what technology is a possible game changer here? So it's open to all of you to share what's in the pipeline. So takers.
So we are looking. Thank you for the question. Maybe I'll give an overview answer for that. We're looking at a lot of different technologies in terms of trying to enable the low carbon energy transition. Particularly looking at different spaces around hydrogen, where if we do decide to go full scale into a hydrogen economy, what we would need to be able to do is to make sure that we have the associated and necessary research infrastructure ready in order to be able to support that deployment here in Singapore. So that's one of the examples that I can give in terms of energy transition. Where if we do manage to go 100% green hydrogen, then maybe the question around carbon capture, utilization and storage may not be that significant, although one of the big industries in Singapore is still the energy and chemicals industry, and there are emissions over there that still need to be treated in some way or form. So in that sense, looking at different ways to either capture the carbon dioxide and store it in an appropriate place, most likely not necessarily in Singapore, but somewhere around the region, that would be one aspect that we could consider. Thinking about putting it into building materials, sustainable building materials, and there are technologies that we have in our stable that we could do for that, or converting the CO2 into higher value products, so like plastics or fuels. There again, we need to bring to bear our entire repertoire in chemistry, catalysis, process engineering, and of course, some of the aspects that Dr. Yeo has also talked about in terms of life cycle assessment, in order to make sure that it really is a good way for us to treat this carbon dioxide, because it won't do us any good if you are going to just create more carbon dioxide by trying to treat the carbon dioxide in the first place. So those are some of the different areas that we are looking at in terms of trying to move forward, both in a low carbon energy transition and also to think about the carbon capture, utilization, and storage. Thank you.
So I think any other panelists would like to say anything about new technologies and game changes that you are looking towards?
Hi, Dr. Hee. Maybe I'll add something.
Okay.
So naturally, maybe quite shamelessly, I'll talk a little bit about batteries. So I think in the game changer for low carbon technologies includes renewables, includes the electrification process. And if you look at renewables, if you go anywhere above 20% of renewables, that's where energy storage becomes very important for grid stability. And not only that, then if you look at electrification process, if you look at charging infrastructures, then energy storage again comes in to help this for the proliferation of the charging infrastructures, both in peak shaving, but both also in grid stability. So overall, holistically, renewables, EV charging, and many different applications that energy storage can bring, I think helps to push our goals towards a more sustainable Singapore and a more sustainable economy. And then if you look at technologies, so maybe not only from A-Star, but if I look at the whole ecosystem including NTU, NUS, universities, and also our industry partners, I think we are quite strongly positioned for this, especially for the energy storage space. So I think from the universities, we are looking at new materials, and that breakthrough will be very important. If we have a breakthrough in really safe, high-performing, and long-lasting batteries, that will make a lot of difference in how we use, consume, and optimize our use of energy. And I think that's quite important. But then further downstream, we are looking at how do we make sure that the thermal management side of the battery pack is well managed, that increase the efficiency, that reduce any catastrophic events. And then lastly, of course, we talk about recycling. That completes the circular thinking, and that completes the value chain to make sure that the whole technology itself is not adding more carbon footprint. And maybe that's a cue for Zhi Quan to come in and because we got to understand what is the whole carbon footprint for all the technologies before we go big into any area. Thanks.
Thanks, Dr. Chiam. So Dr. Yeo, what do you have to add to this?
Right. So in fact, my view on this, there was this mention of possible game changer or what kind of technology. But again, I come from the decision making point of view, whereby again, to answer this question is more of, I envision it as more of a sort of a mix of different technologies, new technologies and innovation, ranging from new materials to renewables to even the infrastructure to enable all these technologies to be deployed. Even from the point of how do we even sort our waste, whereby we live in a country whereby we are so used to convenience where we just dump our waste into a single sort of receptacle. So again, it's about how do we optimize and determine what kind of technologies and mix to enable all these sustainable and sustainability performance moving forward. How do we deploy all these and under what conditions do they make sense? So this is, I think, ultimately what we will be looking for. So again, there will be, I don't think there will be one single technology that will be a game changer, but more of looking at the problem at a more holistic level of how do we deploy these in various contexts. Yeah.
Thank you, Dr. Yeo, for bringing in that perspective about the governance and decision making and choosing the right solution for the appropriate context, because I think it's not just the technology, but how they are deployed and what kind of mix we have. Looking at the clock, I think we are just in time to thank all of the panelists for this very energetic discussion, and for me to hand the session back to Kylie. Thank you so much.